Welcome to our module on working with Python, where we'll explore fundamental concepts and tools for development. Today, we'll focus on essential tools for effective package and text management, crucial for any Python project. Let's begin by understanding how to set up Python packages using pip, your go-to package installer. Pip is the standard package installer for Python, simplifying how you manage external libraries. Understanding pip's role is crucial, as it's the primary system for managing software packages from PyPI, the Python package index. This powerful tool allows you to easily install and manage various software packages from the Python package index. It's important to check if pip is already included with your Python installation, which is often the case. If you have Python 2, 7, 9+, or Python 3, 4+, pip is generally included by default, saving you an extra step. If needed, you can upgrade the EnsurePip module to ensure you have the latest version of pip itself. You can do this by running Python m EnsurePip upgrade in your terminal, ensuring your package manager is current. Alternatively, you can install pip using the getpip py script if it's not present or needs a fresh installation. Simply execute Python getpip py to install pip directly, setting up your package management system. Now, let's explore some essential pip commands for efficient package management in your Python projects. We'll cover how to install, upgrade, and effectively manage your Python libraries, which is fundamental for development. First, let's look at how to install a new package into your Python environment. The pip install command downloads and installs a specified Python package, like requests, directly from PyPI. You use pip install followed by the package name, such as pip install requests, to add new libraries. Next, let's see how to upgrade an existing package to its latest available version. To update a package, use the pip install upgrade command, ensuring you have the newest features and fixes. Simply type pip install upgrade package name to update any installed library to its most current version. Sometimes you need to remove a package, so let's learn how to uninstall one. The pip uninstall command efficiently removes an installed Python package from your current environment. Execute pip uninstall package name to completely remove a library you no longer need from your project. Finally, let's discover how to list all the packages currently installed on your system. To view all installed packages and their versions, simply use the straightforward pip list command. Just type pip list into your terminal to get a comprehensive overview of your installed Python libraries. Effective dependency management is crucial for maintaining clean and reproducible Python projects. The first step is always to initiate a new project, setting the foundation for your work. Then, create a virtual environment to isolate your project's dependencies from other Python installations. Next, remember to activate this isolated environment before you start installing any packages. Once activated, you can safely install all the specific dependencies required for your project. With your environment set up and dependencies installed, you can now confidently develop your project. Finally, when you're done working, deactivate the virtual environment to return to your system's default Python. Today, we'll explore some essential modules from Python's standard library, which are incredibly useful for various programming tasks. These are powerful, built-in tools designed to help you tackle a wide range of programming challenges efficiently and effectively. First up, we have the OS module, which is short for operating system. It allows your Python programs to interact directly with the underlying operating system and manage file paths. Next, we have the sys module, providing access to system-specific parameters and functions. This module lets you access variables and functions that interact with the Python interpreter itself. Then, there's the datatime module, which is crucial for effectively working with temporal data. It provides robust classes for manipulating dates and times, making time-related operations straightforward and efficient. The math module is your essential go-to for performing a wide range of advanced numerical operations. It offers a rich set of mathematical functions and constants, extending Python's basic arithmetic capabilities. Finally, we'll look at the re module, which stands for regular expressions. This module provides powerful support for regular expressions, enabling complex pattern matching in text. Now, let's dive deeper into handling dates and times using Python's DataTime module. We'll cover how to create, format, and perform calculations with date and time objects effectively. Let's start by understanding how to create date objects in Python using the DataTime module. The date, today, method retrieves the current date, and you can construct specific dates using date, year, month, day. This code snippet demonstrates importing the date class, getting today's date, and creating a specific date. Next, let's explore how to create DataTime objects, which include both date and time. The DataTime now method gets the current date and time. Specific objects combine date and time components. Here, we import DataTime, get the current time, and then create a specific date and time object. Now, let's look at how to format DataTime objects into strings and parse strings back into DataTime objects. The SDRFTime method formats a date-time object into a string, while SDRTime parses a string into a date-time object. This code shows formatting a DataTime object into a specific string and then parsing a string back into a DataTime object. Finally, let's explore how to perform arithmetic operations with dates and times using Python. The time delta object represents a duration, enabling you to add or subtract periods from dates and times. This example shows importing time delta, adding 1 day to a DataTime object, and calculating the difference between two. Let's now explore the basic syntax of regular expressions, a powerful tool for text pattern matching. We'll break down the fundamental building blocks that allow you to construct complex patterns for matching text. Literal characters are the simplest. They match themselves exactly within the text you are searching. For example, A matches the letter A, and cat matches the exact sequence of C-A-T. Special characters have predefined meanings, allowing you to match categories of characters rather than specific ones. For instance, \D matches any digit, and \S matches any whitespace character. Quantifiers specify how many times a character or group of characters should appear in the match. Asterisk means 0 or more, plus means 1 or more, and question mark means 0 or 1 occurrence. Character classes allow you to define a set of characters, any one of which can match at a given position. For example, ABC matches A, B, or C, while 0-9 matches any non-digit character. Anchors do not match characters themselves. Instead, they match specific positions within the string. The caret matches the start of a string, and the $$ matches the end of a string. Now, let's explore some common regular expression functions available in Python's RE module. These functions provide powerful capabilities for step-by-step text pattern matching and manipulation. The RE match function checks if a pattern matches only at the very beginning of a string. In contrast, RE search finds the first occurrence of a pattern anywhere within the entire string. The RE find all function retrieves a list of all non-overlapping matches of the pattern in the string. With RE sub, you can replace all occurrences of a specific pattern with a new string. Finally, RE split allows you to split a string into a list, using the pattern as a delimiter. All right, let's wrap up our discussion with a concise summary of the key concepts we've covered in this module. Here are the most important takeaways that will significantly enhance your Python development efficiency and reliability. First, remember that pip is absolutely crucial for efficiently managing and installing Python packages directly from PyPI. Virtual environments are essential. They isolate project dependencies, effectively preventing any potential conflicts between your projects. The Python standard library is incredibly powerful, offering extensive built-in modules for numerous common programming tasks. Specifically, the DataTime module provides robust functionalities, allowing you to manipulate dates and times with great precision. And don't forget regular expressions, accessed via the RE module, which are incredibly powerful for advanced text processing. Ultimately, mastering these fundamental tools will significantly enhance your Python development efficiency, making your code more reliable.